Almost every photograph you have ever seen of the outer solar system was taken by one of two machines. They passed each world once for a few hours and kept going. Neither has ever come back. 722 kilograms each, built to work for 5 years. Tonight I want to follow one of them out past the edge and listen to what it found waiting there. Tonight we follow it the whole way out. Jupiter and a moon on fire. Saturn and a decision that cost one spacecraft its future. Uranus on its side. Neptune. Then past all of it, to the edge of the sun's territory, and the 3 sounds it has sent back from the other side of that boundary. If you stay for these, subscribing helps. That is the whole ask, and I won't mention it again. Nothing here needs remembering. Let it run long and low, the way a radio wave does. We can start. Right now, as you're listening, there is a machine 49 years out from Earth with almost nothing left of itself. Its cameras have been dark since 1990. It is not dying of anything dramatic. It is simply running out of heat. Its power comes from plutonium, decaying at a fixed rate that nobody can slow. 4 watts less every year, and no way to add any. So the mission has spent a decade switching things off, one instrument at a time. The cosmic ray detector went dark last year. The charged particle instrument followed this April. 2 things still work: a magnetometer, which feels, and a plasma wave instrument, which listens. 3 canisters of plutonium, sealed in 1976, still warm enough to run a pair of instruments across 14 billion miles of nothing. It has lost nearly every sense it was built with. What it has left is hearing. And in November of this year, it passes a mark nothing built by anyone has ever passed. 1 light day. 24 hours for a signal to reach it, and 24 more to come back. Hearing it now takes 6 antennas in Madrid working together, combining their power to catch a transmitter weaker than the bulb in a refrigerator door. That was a first, in April of 2024. Ask it a question tonight, and the answer arrives the day after tomorrow. It crossed out of the sun's territory in August of 2012. Everything it has sent since then has come from somewhere no instrument had ever been. Before it got there, the edge was a confident picture. The sun blows a wind of charged particles outward, and that wind carves a bubble in the gas between the stars. The models put that wall at 90 to 100 astronomical units, roughly 9 billion miles. The shape was expected to be a sphere. The crossing was expected to be sharp, weeks, perhaps months, and the magnetic field beyond was expected to turn. 4 predictions: distance, shape, sharpness, direction. It reached 90 astronomical units and nothing happened. 100 and nothing. The instruments still reading solar wind, the models quietly running out of room. 110, still inside. On the 25th of August, 2012, the solar wind essentially vanished and galactic cosmic rays jumped and stayed jumped. It was at 122 astronomical units, so the first prediction was wrong, and wrong in the direction of the solar system being bigger than we thought. These are the 2 spacecraft measuring the same thing 6 years apart. The step in each line is the moment that spacecraft left. But nobody announced anything because a different prediction failing had broken the test. The magnetic field was supposed to swing to a new direction at the boundary. That was the agreed proof. It didn't swing. It held almost exactly where it had been. Without the field turning, the argument inside the mission ran for a full year. What finally settled it was not a particle count and not a picture. It was the plasma instrument hearing something. The gas out there rings at a pitch that depends only on how densely it is packed. Measure that pitch, and you have the density directly. 6/100ths of a particle per cubic centimeter in late 2012. 8/100ths 5 months later, and still rising. That was the proof. Not the wind stopping, the gas singing at the wrong pitch for home. NASA announced it in September of 2013, 13 months after it had already happened. But that sound is a burst, not a tone. It rings when a solar storm arrives and rattles the gas, and it stops when the storm passes, which means the sun is still reaching it. 14 years past the border, weather from home still arrives, months late, crossing several astronomical units, ringing the interstellar gas like a struck bell each time. It left, and it is still not entirely out of the house. I find that harder to sit with than the distance. Between the storms, there should have been silence. That was the assumption, and it held until a graduate student went looking in the gaps. Stella Koch-Ocker at Cornell went through the quiet stretches everybody had treated as empty. They were not empty. There was a signal running through all of them. This is the hum. The gas between the stars has a voice of its own, with nothing striking it at all. It is not loud. It would not be loud if you could stand there. It is simply always present, and its pitch tracks the density of the gas exactly. A reading every 3/100ths of an astronomical unit for years by ear alone. Published in 2021. 14 billion miles out, nearly out of power, down to 2 working senses, and it found something nobody knew was there to find. Which leaves a fair question. How does a 5-year mission to photograph Jupiter end up as the best microphone we have? Engineers, in Florida, in June of 1977, walking out the magnetometer boom by hand. Nothing about this was built to listen to the space between stars. It was built to fly past 2 planets and stop. Everything since is overtime. That part starts with a coincidence. In the middle of the 1960s, a graduate student at the Jet Propulsion Laboratory was working through orbital tables and noticed something nobody had said out loud. 4 outer planets were drifting into the same quarter of the sky at once. Not close together, nothing in the outer solar system is close together, but arranged along a curve that a single spacecraft could follow, if it left at the right moment and never stopped. The arrangement comes around once every 176 years. The last time, Thomas Jefferson was president, and nobody could have used it. The trick that makes it work is gravity assist. You fall toward a planet, bend around it, and leave faster than you arrived. The speed is borrowed from the planet's own motion, and the planet loses an amount too small to measure. Jupiter is slowed by roughly the width of a proton per year. Without it, the trip to Neptune takes 30 years. With it, 12. So the window was open. It was open once, and the people who noticed were in their 20s and 30s. They would be in their 50s when the last planet went past. The mission they were allowed to propose was much smaller than the one they wanted. Congress funded a trip to Jupiter and Saturn. 5 years. 2 spacecraft, in case one failed, which was not pessimism, it was arithmetic. Nothing built then had lasted 5 years in deep space. The rest of the tour was left unsaid and quietly built into the trajectory anyway. They launched in the late summer of 1977, 16 days apart, from the same coast. The second one left first, on the 20th of August. The first one followed on the 5th of September, on a faster path that would overtake it before Jupiter. The names were assigned by arrival order, not departure order, which has been quietly confusing people for half a century. Both rode a Titan rocket with a Centaur upper stage. That was the last push either of them would ever receive from anything. Everything afterwards was gravity and patience. No engine to speed it up, no fuel to spend on going faster, only small puffs of hydrazine to stay pointed. Those puffs are still being spent. 1977 fuel, being used this month. Bolted to the side of each was a gold-plated copper disc, 12 inches across, with a diagram etched on its aluminum cover explaining how to play it. The committee that chose the contents had about 6 weeks. Greetings in 55 languages, thunder, surf, wind, rain, a heartbeat, whale song, a kiss, footsteps. 90 minutes of music from wherever they could get permission in time. Bach and Chuck Berry, and a Navajo night chant, and a Peruvian wedding song, and a Bulgarian shepherdess singing alone. There is a persistent story that the Beatles wanted to contribute and were blocked by their record company. It is probably not true, but it has outlived every correction. What is true is stranger. The record has a cartridge and a stylus mounted beside it, because the committee assumed that whoever found it would have no idea what a groove was. They also etched a map, 14 lines radiating from a point, each one aimed at a pulsar, each marked with that pulsar's rhythm. Pulsars slow at known rates, so the map is also a clock. Anyone who finds it and can read it will know not only where it came from, but when. The chance of that is essentially zero, and everyone involved knew it at the time. They made it anyway, in 6 weeks, while building the spacecraft that would carry it. I think that is the most human thing in the whole story, not the engineering. The decision to write a letter with no address on it. 18 months after launch, the first of them reached Jupiter, and the pictures that came back did not match a single painting anyone had made in advance. The cloud bands were not decoration. They were weather, enormous streams running in opposite directions, tearing at each other along every seam. Between them, at the boundaries, the atmosphere curls into vortices that last for weeks. The great red spot resolved into a storm, with a visible spiral inside it, wider than our entire planet, turning in place since at least 1831, when the modern storm was first recorded. Nothing on Earth lasts like that. Our largest storms live for days. And then, around the planet, where nobody had thought to look, there was a ring. Thin, dark, made of dust rather than ice, and invisible from Earth. It was found because someone decided to point the camera at empty space and take a long exposure. That is the part I keep returning to. Not that it photographed what we expected, that it kept finding things nobody had asked it to look for. 4 large moons went past in a few days, and each one turned out to be a world rather than a rock. Ganymede, wider than the planet Mercury though barely half its mass, its surface cut into long, parallel grooves nobody has fully explained. Callisto, so completely covered in craters that there is no room left for new ones, a surface that stopped changing 4 billion years ago. Europa, smooth as a cue ball, wrapped in brown cracks that run for thousands of kilometers, with almost no craters at all. Something down there is resurfacing it. And Io, which was about to end several assumptions at once. Io was expected to be a dead gray rock, same rough size as our moon, same distance from its parent, same age. There was no reason to think otherwise. 3 days after closest approach, a navigation engineer named Linda Morabito was brightening the edge of an image to bring out background stars. Something was standing off the moon's limb, a faint umbrella of light where there should have been nothing but black. Her first thought was that the camera had failed. Her second was that she was seeing another moon behind Io. She checked the tables. There was no moon there. It was a volcanic plume, 300 kilometers tall, caught in the middle of erupting. Nobody had ever seen an active volcano anywhere except Earth. Not on Mars, not on the moon, not anywhere. In one image that stopped being true. And it had been predicted, barely. 3 scientists had published a paper on Io being heated by Jupiter's pull. It came out 3 days before the encounter. They had almost missed being right. Then the whole surface explained itself at once. Io has no impact craters. Not one has ever been identified, anywhere on it. Every other airless world in the solar system is covered in them. On Io, everything gets buried before it can accumulate. The moon repaves itself faster than the solar system can scar it. Yellow, white, black, orange, sulfur laid down in sheets over and over for 4 billion years. Jupiter pulls one way, the other large moons pull back, and Io flexes between them. The friction of that flexing melts it from the inside. It is being kneaded, and it has been for as long as there has been a solar system. Standing there, the ground would be warm in places and the sky would be filled by a planet 11 times the width of Earth, never moving from where it sits. The encounter lasted about 48 hours at close range. Then, Jupiter's gravity did what it had been brought there to do. It threw the spacecraft onward at a speed it could never have reached on its own, and the planet turned back into a point of light behind it. Ahead, nothing at all, for a year and a half. This is most of what the journey actually is. Long silence, and then a few hours that rewrite a chapter of a textbook. It kept working the whole way. Instruments listening, the dish held steady on a world it could no longer see. And 1.5 billion kilometers ahead, the rings were waiting to stop making sense. But there is no hurry. That is later tonight. There were 2 of them, and so far I have only been following one. The second arrived at Jupiter 4 months after the first, in July of 1979. It came in on a different path, aimed to pass closer to the moons and further from the planet, because the first one had already taken the risk of going in close and survived it. That is the quiet advantage of building 2. The first one finds out what is dangerous. Jupiter's radiation belts are the most violent environment in the solar system outside the Sun. The first spacecraft took a dose that would have killed a person 1,000 times over. So the second was sent through a gentler corridor and spent its time looking sideways instead. It caught the ring again, better lit, and from a different angle, which confirmed it was real and not a flaw in the first camera. 2 instruments, 4 months apart. It watched Io from a different angle and found the volcanoes had not stopped. Some plumes were in the same places. One had gone out, another had started. 4 months is nothing in geological time. On Earth, you would need thousands of years to see a comparable change in a volcanic landscape. On Io, it was enough to redraw the map. And that is the thing about the whole outer solar system that nobody had expected. It was supposed to be finished, cold, old, and done. Instead, almost everything out there was still moving. Then the second one turned toward Saturn as well, on a slower path, arriving nearly 2 years behind. Between Jupiter and Saturn there is a gap of about 650 million kilometers. At the speed these were traveling, around 15 kilometers every second, which would carry you across the Atlantic in 6 minutes, that is still roughly 20 months of nothing. I want to sit in that gap for a moment, because it is most of what the mission actually was. There is no scenery. The planets behind and ahead are points of light. The sun is bright but small, and gives almost no warmth at that distance. The spacecraft is not asleep. It is holding its dish on Earth, running its instruments, measuring a solar wind that is thinning out around it. Every 8 hours or so, it takes a fresh fix on a star to check it is still pointed correctly, and corrects itself with a puff of gas if it is drifted. It uses a star called Canopus for that. Bright, isolated, far from the ecliptic, easy to find, and hard to confuse with anything else. For decades, the way this machine knew which way it was facing was by looking at one particular star and recognizing it. On the ground, the mission has gone quiet too. The Jupiter data will take years to work through. Papers are being written. Careers are being built on 8 days of close approach. And some of the people who will run the Saturn encounter are, at this point, still students, finishing degrees, unaware that the sequences they will one day write are already halfway there. Meanwhile, the spacecraft coasts, losing nothing, gaining nothing, changing nothing except its position. This is the part that documentaries usually cut, because there is nothing to show and nothing happens. I think it deserves a minute anyway, because it is the true texture of the thing. Because the achievement is not the flyby. The flyby lasts hours. The achievement is 20 months of a machine holding its aim across 500 million kilometers with nobody able to touch it. And then Saturn begins to grow in the cameras. At first, it is a point of light, indistinguishable from a star except that it moves against the others. Then it becomes a point with something faint on either side of it. Then, over weeks, the something resolves. Everyone knew Saturn had rings. Galileo saw them in 1610 and could not work out what he was looking at. He described handles or ears on either side of the planet, and then 2 years later they vanished because the ring plane had turned edge-on to Earth. By the 1970s, the picture was settled. A few broad rings, labeled A and B and C, separated by a gap. That is what everyone expected the cameras to show. The same picture they already had, at higher resolution. Confirmation, and perhaps a refinement of the gap widths. What came back instead broke the classification entirely. The broad rings were not broad at all. As the resolution improved on the approach, each one resolved into hundreds and then thousands of separate ringlets, and the count kept rising every week. The A ring alone was thousands of concentric bands. The B ring was denser and even more finely divided. Some ringlets were only a few kilometers wide. Some had edges so sharp the brightness dropped to nothing across a distance smaller than a city. That should not be possible. There is nothing obvious keeping them separate. Particles in adjacent orbits should smear together over time. They had not smeared. Something was actively maintaining the structure against 4.5 billion years of collisions. And 45 years later, we are still arguing about most of what that something is. The gap that everyone had learned about turned out not to be empty either. There was material inside it, in its own thin rings. It is worth stopping on the scale of this because the numbers are genuinely strange. The main rings are about 270,000 kilometers across. That is most of the way from Earth to the Moon. And they are, in most places, only tens of meters thick. If you shrank the rings to the width of a football pitch, they would be thinner than a sheet of paper. They are made almost entirely of water ice, in pieces from dust grains up to house-sized boulders, all going round in their own orbits. From above, it reads as a solid surface, bright enough to see through a small telescope from a garden. From the side, it nearly disappears, and sometimes it does. The spacecraft flew through the ring plane, which was the most dangerous moment of the whole encounter. It was aimed at a gap, and it hit dust anyway. The instruments recorded thousands of individual impacts, each one a grain arriving at tens of kilometers per second. Nothing large enough to kill it. But nobody knew that in advance, and there was no way to steer once committed. Both spacecraft crossed. Both survived. That is partly design and partly luck, and the mission was honest about the ratio. And then, in the images, something appeared that had no explanation at all. Dark markings, lying across the B ring like spokes on a wheel. Not gaps in the ring, not shadows cast by anything. Patches of something darker, drawn radially outward across the ringlets, cutting straight across the direction the material is traveling. That should be impossible. Particles closer to Saturn orbit faster than particles further out. Any radial feature should shear apart within a few hours. The inner end dragged ahead, the outer end left behind, until the whole thing is pulled into a curve and then a smear. The spokes did not. They formed, held their shape for a few hours, and faded. Then they faded, and new ones appeared, in the same part of the ring, doing the same thing over again. Whatever draws them was still drawing. Whatever they are not behaving like matter in orbit. They are behaving like something being switched on. The leading explanation is that they are extremely fine dust, lifted just above the ring plane and held there by electric charge. The ring particles are being charged by the plasma around Saturn, and the smallest grains, micron-sized, respond to the magnetic field more than to gravity. So the pattern rotates with Saturn's magnetic field rather than with the orbits of the particles. That is why the shape survives. The pattern is not moving with the ring particles at all. It is being drawn on them from outside by a field that turns at its own rate. It is an idea with good evidence behind it, and it is still not entirely settled. Later observations found the spokes come and go with the seasons. They appear when the rings are near edge-on to the sun, and disappear when the rings are tilted toward it. That took decades to establish, and it happened long after both spacecraft were gone. I like that the answer took 30 years, required a second spacecraft that arrived decades later, and is still only partial. This is what the mission actually delivered, over and over. Not answers, better questions with data attached. Before this, the rings were essentially a curiosity, a decoration on a gas giant, drawn in every textbook, understood well enough that nobody expected trouble from them. Afterwards, they were an active system with weather in it, and a physics nobody had written down.
And the strangest object in the whole arrangement had not even been noticed yet, because it is faint and thin and sits well outside the rings everyone was looking at. There is a ring further out, much fainter than the others, discovered by the first spacecraft. It is called the F ring, and it does not look like a ring at all. It looks braided. In the images from the first encounter, it appeared as 2 or 3 separate strands twisted around one another like rope. Orbital mechanics does not permit that. Strands in adjacent orbits cannot wind around each other. They simply drift apart at different rates. The images were checked for artifacts. They were not artifacts. And then the second spacecraft arrived 20 months later, looked at higher resolution, and did not see a braid at all. It saw 4 or 5 separate strands, kinked and clumpy, crossing only in appearance. So the braid was never a structure at all. Later work established it as a single continuous spiral of debris, unwinding slowly, whose windings overlap when you happen to view them edge on. The explanation arrived with 2 small moons found in the same images, one just inside the ring and one just outside. They were named Prometheus and Pandora. For 40 years, the textbook said the 2 of them squeezed the ring from either side. That turned out to be wrong. Work published in 2024 found the confinement comes from Prometheus alone, through a resonance, and that it is intermittent rather than constant. Pandora, it turns out, is not shepherding anything. It simply happens to orbit nearby, and for 4 decades, everyone assumed that proximity meant a role. Prometheus is a lumpy object roughly 130 kilometers along its longest axis. Pandora is smaller. One object the size of a city, intermittently shaping a structure 140,000 kilometers out from the planet. The braid was the ring caught at one angle, in 1 week in 1980, by a camera that could not quite resolve it. 20 months later, when the second spacecraft looked, it had moved on into a different one entirely. Nobody has ever seen that exact arrangement again, because nobody has looked from that angle at that moment. That is true of an enormous amount of what these 2 machines recorded, and it is easy to forget when the same images are reprinted for 40 years as though they were permanent. They were the only witnesses, and they were passing. Every image is a single frame of a system that kept moving after the camera was gone. There were other moons in those images too, small, irregular, previously unknown. Most of them found not during the encounter but months afterwards by people working through the returned frames one at a time. 3 were genuinely new: Atlas, Prometheus, and Pandora. A 4th, Pan, was pulled out of the archive 9 years later by someone rereading old frames. None of that, though, not the ringlets, not the spokes, not the braid, was the reason the first spacecraft had come to Saturn at all. There was one target at Saturn that mattered more to the mission than the rings, more than the moons, more than the planet. A moon with an atmosphere. Triton is the only moon in the solar system with a thick one, denser at the surface than Earth's, mostly nitrogen, with a haze that had defeated every telescope. In 1944, an astronomer named Gerard Kuiper had detected methane there, which meant air, which meant chemistry, which meant it might be the most interesting object between here and the stars. For the mission planners, this was not a side trip. It was arguably the whole point of going. And reaching it properly required a decision that would end that spacecraft's planetary career permanently on the day it was made. To pass close to Triton, it had to come in under Saturn's south pole on a particular curve. That curve would fling it up and out, away from the plane in which all the planets orbit, on a path that could never reach Uranus or Neptune. Every target after Saturn for that spacecraft would be gone. There would be nothing ahead of it but distance. The other one would have to carry the rest alone, and the other one would then have to survive another 8 years to do it. So the choice was straightforward to state and extremely hard to make, and it was made by people who would have to live with it for the rest of their working lives. Take the closest look anyone would get at Triton for a generation, and give up every target after it. Or skip it,
Keep a paper option open to send that spacecraft onward to Pluto and leave the most chemically interesting body in the outer system unvisited. They chose Titan. It is one of the very few decisions in the whole mission that people still argue about, 46 years later. What happened next is the reason I wanted to tell this part slowly. Because they were right to choose it, and it did not work. At least, not in the way anybody in that room was hoping for. On the 12th of November 1980, the first spacecraft passed within about 4,000 kilometers of Titan. That is close. Closer than the Moon is to Earth by a factor of nearly 100. Everything on board was pointed at it. Cameras, spectrometers, the radio science experiment. This was the appointment the entire flight plan had been bent around for 3 years, and the cameras saw nothing. Not nothing in the sense of empty, nothing in the sense of a wall. Titan is wrapped in an unbroken orange haze that goes all the way down, featureless. No gaps, no thin patches, no window anywhere. The cameras returned a smooth apricot ball with no detail on it at all. No cloud structure, no bright patches, nothing that could be tracked from one frame to the next. There is a particular kind of silence that follows that in a control room, and I have read a lot of accounts of it. They had given up every target after Saturn for this, and they had known in advance that they might see exactly nothing. But calling it a failure is only fair if photographs are the only thing that counts, and they are not. But the instruments that did not need to see got a great deal, and one of them got the single most valuable measurement of the encounter. The atmosphere was measured properly for the first time. Mostly nitrogen, like ours, but the surface pressure turned out to be about 1.5 times Earth's. A moon a fraction of Earth's size, holding on to air thicker than the air we live in. Surface temperature around 94 Kelvin, 180 degrees below zero. And methane, in quantities that made no sense as a leftover. Sunlight destroys methane over geological time. If it is still there, something is replenishing it. The haze itself turned out to be the product. Complex organic molecules built by sunlight, breaking apart methane and nitrogen high up, then drifting down as a slow chemical snow. So the thing that blocked the view turned out to be the discovery. The haze was not in the way of the answer. It was the answer. At that temperature and pressure, methane can exist as a liquid, which raised a possibility nobody could confirm and nobody could dismiss. That underneath the haze, there might be lakes, not of water, of methane and ethane, at 180 below, sitting on a crust of water ice hard as rock. It took another 24 years, a different spacecraft, and a small probe dropped through the haze on a parachute to find out whether that was true. It was true. But that is somebody else's story, and it happened long after the machine that raised the question had left. The price came due immediately. The trajectory that took it under Titan threw it up out of the plane of the solar system at about 35 degrees to the ecliptic. Everything else, every planet, every asteroid, the whole flat disk that everybody draws when they draw the solar system, was now below it and falling away behind. There was nothing ahead. No target, no encounter, nothing to point a camera at that would grow larger. For a spacecraft built as a planetary explorer, that is the end of the job. It was 1980. The machine had been flying for 3 years and had done everything it was funded to do. The reasonable expectation was that it would go quiet within a few years, drift outward, and be forgotten. Instead, it is still transmitting, 46 years later, and it is the furthest human object in existence, and everything it is famous for now happened after it stopped being useful. I keep coming back to that because it says something about how badly we predict which parts of our work will matter. The Titan encounter is usually written up as the moment Voyager 1's planetary mission ended, and in the narrow sense that is correct. It is more accurate to say it is the moment its mission changed into the one that made it immortal. Meanwhile, the second spacecraft was still coming, 20 months behind, carrying instructions that were being rewritten while it flew. It had passed Jupiter 4 months behind, taken a slower route, and was now 20 months from Saturn, with instructions that had been rewritten while it flew. And because the first one had already taken Titan and returned the data, the second one did not have to go anywhere near it. That mattered more than it sounds. If the Titan pass had failed, the backup plan was to send the second spacecraft instead, and that would have cost 2 planets. The first one succeeded at the part that mattered, so the second one was released from the obligation and allowed to go on. The two are usually talked about as twins. They are better understood as a relay. One took the full radiation dose at Jupiter and came away with damaged timing in an instrument, so the other could be routed through a gentler corridor. One spent its own future on Titan, so that the other one would never have to. Neither of them knew any of this. They are aluminium and wire and a computer with less memory than a single photograph on your phone. But the shape of what they did together looks like a decision made by something, and I do not think it is sentimental to say so. It was made by people, over years, in rooms, in arguments that are still remembered by the people who were in them. The machines simply carried it out exactly. The second spacecraft reached Saturn on the 26th of August, 1981. It arrived into a system that was now partly understood, and that changed the whole character of the visit. The first encounter had produced questions. This one arrived carrying them. The first encounter had produced questions. This one was sent to answer them. It went closer to the rings and looked at them at higher resolution, and the ringlets simply subdivided again, structure inside structure, all the way down to the limit of the camera. Structure on top of structure, down to the limit of what the camera could resolve, and no sign of a smallest scale. It watched the spokes form and fade over hours, and confirmed they were not an artifact of one encounter. It found the F-ring rearranged, kinked and clumped, but no longer braided, and it turned to the moons properly, which the first one had mostly passed at a distance. Saturn's moons turned out to be a set of small worlds with almost nothing in common except that they orbit the same planet. No family resemblance at all. Mimas is 400 kilometers across and carries a single crater a third of its own width. The impact that made it came very close to breaking the moon apart. There are fracture lines on the opposite side that may be the shock arriving from the other direction. Enceladus is smaller still and brilliantly white, the most reflective object in the solar system, throwing back nearly all the light that reaches it. Parts of its surface are heavily cratered and clearly ancient. Other parts are smooth and almost blank, which means they were resurfaced, which means it had internal heat. On a body 500 kilometers across, 4.5 billion years old, that should not be possible. It should have frozen solid long ago. The images could not explain it. All they did was establish, beyond argument, that it needed explaining, which took another 24 years and a spacecraft that could stay. Iapetus is the strangest of them. One hemisphere is bright as snow, the other is darker than coal, and the boundary is sharp. It was noticed in 1671 by Giovanni Cassini, who saw the moon on one side of Saturn and not the other, and correctly concluded that one face must be dark. 310 years later, the cameras confirmed it and could not say why. Hyperion is not round. It tumbles chaotically, with no fixed axis, so its day has no length you can state. Tethys carries a canyon that runs most of the way around it. Dione has bright, wispy streaks across its trailing side that looked, in these images, like frost. Much later they turned out to be walls of ice, cliffs, seen edge-on from a distance. Not one of these had been more than a point of light before. In 2 encounters, they became places. And the discoveries kept coming from the second spacecraft right up to the moment, on the way out of the system, when something went badly and unexpectedly wrong. As it left Saturn, it needed to swing its scan platform, the moving mount that carries the cameras, to keep pointing at targets while the geometry changed fast. The platform jammed. It stuck in one position and would not turn in azimuth, and the whole departure sequence depended on it moving. For a while, the mission believed it had lost the cameras entirely, which would have meant no Uranus, no Neptune, and the end of the tour 8 years early. What happened next is my favorite piece of engineering in the whole story. The spacecraft was about 1.5 billion kilometers away, which is the number that makes the rest of this story remarkable. A command sent from Earth took roughly an hour and a half to arrive, and any answer took another hour and a half to come back. So every single test was a 3-hour round trip, and there was no way to look at the hardware. They could not see it, touch it, or ask it anything that got a quick reply. What they did was build a copy on the ground and break it the same way. There was an identical scan platform gear assembly at the laboratory. They ran it hard until it seized, then took it apart to see what had happened. The lubricant had migrated out of the gear train under high-speed slewing, and the mechanism had effectively run dry and galled. That gave them a hypothesis with a cure attached. If the damage was not permanent, the lubricant would redistribute given time and gentle use. So the instruction was patience. Leave it alone. Then move it slowly, in small steps, at low rates, and see whether it responds. It responded. Over weeks, the platform came back, not to full speed, and never trusted at high slew rates again, but working. The flight rules were rewritten around the limitation. No fast slews. Plan the sequences so the platform never has to hurry. Every observation at Uranus and Neptune afterwards was designed around a joint that had once seized and might again. They diagnosed a mechanical failure on a machine they could not observe by destroying its twin on a bench, and then nursed it for 8 more years and 2 more planets. That impresses me more than the photographs do. There is a version of this story where the platform never unsticks, and the mission ends at Saturn with both spacecraft, and Uranus and Neptune stay unvisited to this day. That version was close. It was a few weeks of careful, slow commands away. And this is a good moment to say something about what these machines actually are, because it is easy to imagine them as sophisticated. The computers on board hold, in total, less than 70 kilobytes of memory. That is smaller than a single low-resolution image on the device you are probably holding. There is no hard drive. Data is stored on magnetic tape, on a recorder that has to physically wind and rewind. The tape recorder on each spacecraft, a motor, a spool, and tape that physically has to move, was built to run for a few years. Both ran for decades. The transmitter that sends everything home puts out about 23 watts. A domestic light bulb is brighter. By the time that signal reaches Earth, it is spread so thin that the antennas here receive something on the order of a 10/1000th of a billionth of a watt. We hear it anyway, because the dishes are 70 meters across. The receivers are chilled to a few degrees above absolute zero, and we know exactly what to expect and when. Everything about this is thin margins held open by care and by people who kept deciding it was worth the trouble. There is no redundancy left to spare, no spare fuel, no possibility of repair. There never was any of that. It has been like this since the day it left the ground in 1977, and everyone involved knew it. The astonishing part is not that things went wrong at Saturn. It is that so little did, for so long, so far away. The second spacecraft left Saturn in the autumn of 1981, on a path bent toward a planet nobody had ever visited. It would take 4.5 years to get there, which is longer than the entire mission had originally been funded to last. Behind it, Saturn shrank into a crescent, lit from behind, rings throwing their shadow across the cloud tops, a view no one on Earth can ever have. From here you can only see Saturn lit from the front. To see it backlit, you have to be beyond it, and only 2 objects ever have been. Ahead there was nothing again, for longer than before. 4.5 years is enough time for the people running a mission to change, and they did. Some of the original team retired during that cruise, others moved to different projects. New people arrived who had been at school in 1977. The spacecraft did not notice any of it. It held Canopus in its star tracker, held its dish on Earth, and coasted. There was a real question during those years about whether anyone would still be funding this when it arrived. The mission had been approved to Saturn,
Everything past Saturn was, formally, an extension that had to be argued for. It was argued for, repeatedly, in budget cycles that had nothing to do with orbital mechanics. The argument that worked was simple. The spacecraft is already there, already flying, already aimed. The planet will not be reachable again for a lifetime. Uranus had never been visited and, as of tonight, has never been visited again. Everything our species knows from close range about that planet comes from a few hours of one January morning in 1986, and nothing has been added since. That is worth sitting with. One pass, one machine, 40 years ago, and it is still the entire close-up record. There are missions being proposed now to go back. The most serious of them would launch in the 2030s and arrive in the 2040s. The scientists writing those proposals know they may not see the results. That is normal in this field, and it is one of the quietly extraordinary things about it. People routinely commit decades to results they will not be alive to read. You work on something that will report back after you have stopped working. In the meantime, the spacecraft coasted outward through the middle of the 1980s, getting colder, dimmer, and further from any help than anything had ever been. Sunlight at Uranus is about 1/400th of what falls on Earth. It is a twilight world even at noon. The cameras would have to expose for much longer, which meant holding perfectly steady, which meant the platform that had seized was going to matter again. They practiced. They rewrote the sequences. They planned an encounter around a joint they did not fully trust. And on the 24th of January 1986, it arrived. It found a planet lying on its side, a moon assembled from the wrong pieces, and, 4 days later, news from home that took it off every front page. That is where we go next. Uranus was discovered by accident in 1781 by a musician. William Herschel was a composer and organist who built his own telescopes, and he found it while systematically surveying the sky for double stars. He thought it was a comet. It took months of observation by several astronomers before anyone accepted that a new planet had been added to the solar system. It was the first planet ever discovered, rather than simply known. Every other one is visible to the naked eye and has been watched since prehistory. For 205 years after that, it stayed a pale disk in a telescope. Nobody could see anything on it. By 1986, 2 centuries of watching from Earth had established 3 things about it, and all 3 were strange. The first is the tilt. Every other planet spins roughly upright relative to its orbit around the Sun. Earth leans about 23 degrees, which is what gives us summer and winter. Uranus leans 98. It is lying on its side and rolling around the Sun rather than spinning under it. Nobody knows why with certainty. The leading idea is a collision early in the solar system's history with something Earth-sized or larger. The consequence is seasons unlike anywhere else. Each pole spends 42 years in continuous sunlight, then 42 years in continuous dark. When the spacecraft arrived, the South Pole was pointed almost directly at the Sun. It was flying at a planet lit like a target. The second known strangeness was the rings, and the way they were found is almost as odd as the planet. They were found in 1977, the same year the spacecraft launched, and found by accident. Astronomers were watching Uranus pass in front of a distant star to measure the planet's atmosphere by how the starlight dimmed. The star blinked out several times before the planet arrived, and several more times after it passed. Something narrow and dark was crossing in front of the star on both sides. Uranus had rings, and nobody had ever seen them. They are nothing like Saturn's. Narrow, dark as charcoal, widely separated, made of material that reflects almost no light. The third strangeness is that the planet gives out almost no internal heat of its own, which sets it apart from every other giant in the system. Jupiter, Saturn, and Neptune all radiate more energy than they receive from the Sun. They are still cooling from formation. Uranus barely does. Whatever happened to it early on, whatever knocked it over, may also have drained the heat out of it,
and that is still an open question.
So the spacecraft was arriving at a world tipped over onto its side, ringed in charcoal, and colder in its interior than anything of that size has a right to be. It had 4.5 years to prepare, and one shot lasting about 6 hours. And it arrived into the worst light of the entire tour, at a planet that gives back very little of the little it gets. Sunlight at Uranus is roughly 1/400th of what falls on Earth. The cameras needed exposures long enough that the spacecraft's own motion across the scene would smear every frame into uselessness. The solution was to rotate the entire spacecraft slowly during each exposure, at exactly the rate that canceled the motion, turning the whole machine into a tracking mount. This had to be done with thrusters, on a spacecraft whose camera platform had seized 4 years earlier and could not be slewed quickly. It worked. The images came back sharp, and they showed a planet with nothing on it whatsoever. No bands, no spots, no structure of any kind. A flat, featureless, pale blue-green disk. No bands, no storms, no structure at all that the cameras could resolve. It was, visually, the most disappointing planet of the tour, and I think that is worth being honest about rather than dressing up. After months of imaging, only about 8 cloud features could be found well enough to track, and those gave a rotation period of about 17 hours. But the raw impression was a blank ball, and the images from that encounter still look like a paint sample. The reason is the atmosphere is deeply hazy, and the planet is so cold that most weather sits far below the visible layer. There is one further oddity. The magnetic field is tilted about 59 degrees from the rotation axis, and it is not centered on the planet. It is offset, closer to one side, emerging from a point roughly 1/3 of the way out from the middle. On Earth, the magnetic field is roughly aligned with the spin and roughly centered. On Uranus, it is neither. That suggests the field is not generated deep in a metallic core the way ours is, but in a shallower layer, possibly a mantle of water, ammonia and methane under enormous pressure. The spacecraft found the same thing at Neptune 3 years later, which turned one anomaly into a pattern, and the pattern is still being worked on. It also found 10 new moons in 6 hours, none of which had ever been seen from Earth. An 11th was in the images too, and nobody noticed it for 13 years. Small, dark, irregular, most of them under 150 kilometers across, and too faint to have been found any other way. And it found that the rings contain very little dust, which means something is clearing it out, which points back to more shepherd moons than were found. So the planet itself was blank, and the system around it turned out to be crowded and complicated. That is roughly the opposite of what everyone expected, and the second time on this tour that the interesting thing turned out to be beside the target rather than on it. But the encounter was not remembered for any of that, and it is not what anyone thinks of when they think of Uranus. It is remembered for one moon, about 500 kilometers across, which the flight plan had almost skipped. It is remembered for Miranda. Miranda is small. You could fit it inside England with room to spare. Bodies that size are supposed to be simple. Too little mass to hold internal heat, too little gravity to reshape themselves. The expectation was a cratered ball, geologically dead since shortly after it formed, of interest mainly for its craters. The images that came back do not look like a moon. They look like several different moons, cut up and reassembled by someone who was not paying attention. There are areas of ancient, heavily cratered terrain, exactly as predicted, and if the whole moon had looked like that, nobody would have written a paper. And running through them, with sharp boundaries, are oval regions of grooved and ridged material, parallel scarps and troughs like plowed fields seen from the air. They are called coronae, and 40 years later there is still nothing else quite like them anywhere in the solar system. The boundaries between the old terrain and the coronae are abrupt. One landscape simply stops and another begins. And on one edge of one of them, there is a cliff. Verona Rupes is a fault scarp on Miranda's surface, and NASA puts it at over 6 miles high, about 10 kilometers. Early estimates from that single oblique view ran as high as 20. There is no stereo coverage, so the uncertainty has never been closed. Either way, it is the tallest cliff we know of anywhere. On a moon you could walk around in a few weeks. Miranda's gravity is so weak that if you stepped off the top, you would fall for something like 10 minutes before reaching the bottom. You would be moving fast enough at the end that it would still kill you, but you would have 10 minutes to think about it. How Miranda came to look like this is unresolved. One early idea was that it was shattered by an impact and reassembled from the pieces, which is where the picture of a moon glued back together comes from. That has largely fallen out of favor. Current thinking involves internal processes, warm ice rising, driven by tidal heating in an era when Miranda's orbit was more stretched. Which is to say, it was warm once, it moved, and then it stopped and froze in that position. Either way, the honest answer is that a 500-kilometer ball of ice did something nobody has a settled explanation for. And we have exactly one set of close images to work from. Every image we have of it was taken during a few minutes of one pass in January of 1986 by a camera that was already moving away. Half of Miranda has never been photographed at close range. It was in darkness when the spacecraft went by, and nothing has been back. There is a hemisphere of a world in this solar system that no human being has ever seen. That is true of a surprising amount of the outer solar system, and the Uranian moons are the worst case of all. The encounter lasted about 6 hours at close range. Then the geometry opened out, Uranus shrank behind, and the spacecraft was aimed at Neptune with about 3.5 years to run. The results went to the science teams, the press conference was scheduled, and the images were released. All of this arrived on the 24th of January, 1986. 4 days later, on the 28th, the Space Shuttle Challenger broke apart 73 seconds after launch, and 7 people died. I want to be careful here because there is a way of telling this that uses those deaths as a plot device, and I do not want to do that. What is factually true is this. The Uranus results arrived in the same week, and afterwards, nobody was reading them. The agency that had just completed the first and only close survey of a planet was, within 4 days, in the worst crisis of its existence. The Uranus press coverage stopped. The scientific papers were published on schedule and were read by the people who read scientific papers. The wider public largely never heard what was found at Uranus, and to a great extent still has not, 40 years later. Ask most people what we know about Uranus, and the answer is a shrug. And there is a reason for that shrug, and it is not indifference. It is that the one time we went, the news cycle was occupied by something unbearable. The spacecraft itself, of course, registered nothing at all. It was already 3 days past the planet, accelerating, with its next instructions loaded. It had no way to know that anything had happened, and there was nothing in its instructions that would change. The people running it went to work through it anyway, because the next encounter was 3.5 years out, and the sequences had to be written. There is something in that I keep turning over. The machine kept doing the thing it was told to do in 1977, through everything that happened at home, without knowing any of it. That is not comfort exactly, but there is something in it. The shuttle program stopped flying for 2.5 years while the failure was understood and the vehicle redesigned. Budgets were re-examined. Several planetary missions were delayed or canceled outright in the years that followed. The mission that was already flying, that cost nothing more to continue, and that could not be stopped even if anyone had wanted to, kept going. By the time Neptune arrived in 1989, the political situation was different again, and the encounter got the attention Uranus never had. The last, first-time visit to a planet by anyone, ever, so far. Meanwhile, there were 3.5 years of empty crews to fill, and a spacecraft getting steadily further out of reach. The spacecraft was now more than 4 billion kilometers out. Signals took over 4 hours each way. The transmitter power reaching Earth had fallen to a level that required the receiving antennas to be upgraded on the ground while the spacecraft was in flight. So during that cruise, the deep space network was rebuilt around it. New antennas were added at Canberra,
Existing dishes were linked together to work as one, including radio telescopes that were not part of the network at all. For the Neptune encounter, the Very Large Array in New Mexico, a radio astronomy observatory with no connection to spacecraft tracking, was wired in to help catch the signal. That is the part people rarely mention. The mission got harder every year, and the response was to keep improving the ground. The spacecraft could not be upgraded, nobody could reach it. So Earth was upgraded instead. Software was also rewritten in flight, more than once. The onboard computers were reprogrammed to use better image compression, so that more pictures could be squeezed through a signal that was getting weaker every month. The engineers were, in effect, teaching a machine built in the mid-70s new techniques invented after it left. It accepted every one of them. A machine designed before the software existed, taking instruction from techniques invented after it left. There is a version of this story where that is presented as a miracle. It is not a miracle, it is margin. The people who built it left room they did not know they would need, because they had been trained by earlier missions that ran out of room. Some of that margin is still being spent today, 4 decades later. Through 1987 and 88, the cruise continued, quiet and cold, with almost nothing to report to anyone. The planning for Neptune became the most complicated sequence anyone had yet attempted, because Neptune came with a problem attached. The mission wanted a close look at Triton, its large moon, which was known to be strange. But Triton orbits backwards, and getting to it meant passing very close over Neptune's north pole and being bent sharply downward. It was, structurally, the same choice as Titan. Take the moon and give up the future path. Except this time there was no future path to give up. Neptune was the last planet in the sequence, so they could take it without cost, and they did. And they aimed for a pass about 5,000 kilometers above Neptune's cloud tops. That is closer to a planet than either spacecraft had ever flown, closer than most satellites orbit the Earth. At that range, a navigation error of a few hundred kilometers would have meant hitting the atmosphere. They were arriving at a world whose position was not precisely known. Neptune had been discovered in 1846 and had not yet completed a single orbit since. It takes 165 years to go round the Sun once. When the spacecraft launched, Neptune had not returned to where it was when it was found. The final approach was navigated by watching the planet itself grow in the cameras and correcting as they went. The last course correction was made only a few days before arrival, on a target whose position was still being refined as they approached. And on the 25th of August, 1989, 12 years after leaving Florida, the second spacecraft passed over the North Pole of Neptune. It was the last time anything built by us would arrive somewhere new in the solar system for a long while. After Neptune, the tour was over. There was nothing else on the route. What it found there in those few hours was the most surprising set of results of the entire mission, on the coldest world it ever reached. And a few months later, on its way out, it was going to turn around and take a photograph that had nothing to do with science at all. A photograph that was not in the original plan, and that one member of the imaging team had been pushing for over years. That is the next part. There is no hurry about any of it. It kept for 12 years out there in the dark. It will keep for another few minutes. It was the last first-time arrival at a planet that anyone has managed. And 37 years later, it is still the last. Neptune was found with mathematics before anyone pointed a telescope at it. Uranus was not moving quite the way the equations said it should. Something further out, unseen, was pulling on it as it went round. 2 people worked out where that something had to be. Urbain Le Verrier in France and John Couch Adams in England, independently in the 1840s. Le Verrier sent his prediction to an observatory in Berlin. They found the planet the same night, within a degree of where he said it would be. That was the 23rd of September, 1846. A planet located by arithmetic alone, in the dark, from nothing but the way its gravity disturbed the motion of a neighbor nobody had connected it to. Nothing else in the history of astronomy has ever been quite that clean, before or since. By 1989, Neptune had still not completed a single orbit since that night. It takes 165 years to go round the Sun once. It would not return to the spot where it was discovered until 2011. So when the spacecraft arrived, the planet had been known for 143 years and had never been all the way round. That is also why its position was still not precisely known when the spacecraft was closing in on it. The approach had to be navigated by watching Neptune itself grow in the cameras, measuring where it actually was, and correcting on the way in.
The final aim point was about 4,800 kilometers above the cloud tops.
That is closer to a planet than either spacecraft had ever flown, closer than most satellites orbit Earth. It had to be that close because of where it needed to go next. Triton orbits Neptune backwards, and reaching it meant threading over Neptune's north pole and being bent sharply downward on the far side, which meant that after Neptune, the spacecraft would be heading below the plane of the solar system at about 48 degrees and would never come back to it. Structurally, this was the same choice they had faced at Titan 9 years earlier. Take the moon and give up everything that came after it on the route. The same trade, on the same kind of trajectory, with the same people making it. Except this time, there was nothing after. Neptune was the end of the sequence. So this time they could spend the trajectory freely, without giving anything up. And they did.
On the 25th of August, 1989,
12 years after leaving Florida, it went over the top of the last planet. And Neptune, unlike Uranus, was not blank. It came up a deep, saturated blue, much stronger than its neighbor, though the two planets are close in size and composition. The color comes from methane in the upper atmosphere absorbing red light. Why Neptune is so much bluer than Uranus is still not fully settled. And there was weather on it. Obvious, structured, visibly moving weather on a planet where there is almost no energy to drive any. A dark oval storm sat in the southern hemisphere, about the size of Earth, with bright cirrus clouds streaming around its edges. It was named the Great Dark Spot, and the parallel with Jupiter's storm was immediate and obvious. Bright white clouds raced around the planet, one of them so fast, relative to the storm, that the team nicknamed it the Scooter.
Those clouds turned out to be methane ice crystals, high in the atmosphere, casting shadows on a cloud deck 50 kilometers below them. Nobody had ever photographed a cloud shadow on another planet before. It is an ordinary sight from an aeroplane window, and an extraordinary one from 4 billion kilometers. Then, they tracked those clouds from frame to frame, measured how fast they were moving, and the numbers did not make sense. Neptune is 30 times further from the Sun than Earth. It receives about 1,000th of the sunlight we do. Weather is driven by heat, and heat out there comes almost entirely from a sun that is a bright star and nothing more. There is almost nothing to drive anything. And yet the winds at Neptune reach around 2,000 kilometers an hour. NASA calls it the windiest world in the solar system, and that is the careful phrasing, because Saturn's equatorial jet is in the same territory. But Neptune has no business having weather like this at all, and Saturn does. It is twice as close to the Sun and radiates a great deal of internal heat. Neptune radiates internal heat too, more than twice what it absorbs from sunlight. So there is a source down there, still warm after 4.5 billion years, driving an atmosphere the Sun has effectively abandoned. Where exactly that heat comes from is another open question. It may be residual energy from formation, or from the slow separation of materials inside. The magnetic field turned out to be tilted steeply from the rotation axis and offset from the center of the planet, just as Uranus's had been 3 years earlier. One planet like that is an anomaly. 2 is a class, and it changed how the interiors of both are modeled. The rings were confirmed as complete circles, which had been genuinely uncertain. Ground-based observations had suggested incomplete arcs. They are complete, but with dense clumps in them where the material bunches up, which is why they had looked broken from Earth. 6 new moons were found, none of which had ever been seen. And the Great Dark Spot, the single most photographed feature of the encounter, the image that ended up in every textbook,
was gone within 5 years. When the Hubble telescope looked in 1994, the storm had vanished, and a new dark spot had appeared in the northern hemisphere instead. So the thing the spacecraft is most famous for finding at Neptune no longer exists, and its replacement is somewhere else on the planet. There is something oddly moving in that rather than disappointing, and it changes what the photograph is. The image everyone knows is a photograph of a weather system that lasted a few years, taken by something passing at 60,000 kilometers an hour. It is not a portrait of Neptune. It is a portrait of one particular week on Neptune, in the summer of 1989. That is true of nearly everything in this film, and it is worth saying plainly rather than leaving it implied. Io's plumes have moved. Saturn's F-ring has rearranged. The Great Red Spot has shrunk by a third since these images were taken. These are not photographs of how the solar system is. They are photographs of how it was, for a few hours, 40-odd years ago. Everything out there kept going after the camera passed, and almost none of it has been photographed again from close range by anyone since. That is the part that quietly changes how I look at these images, and I did not expect it to. They are not reference. They are testimony. One witness, one pass, no second opinion available, and the witness has been steadily leaving ever since. Neptune took about a day of close observation. Then the spacecraft passed over the North Pole, was bent downward by the planet's gravity, and fell toward its last target. 5 hours later, still falling away from the planet, it reached Triton, the last object on the route, and the strangest one. And Triton is where the whole 12-year journey stops being a survey and becomes something stranger. Because by every rule anyone had at the time, Triton should have been geologically dead for 4 billion years. It is small, smaller than our moon. It is unbelievably cold. It is 4.5 billion years old. By every rule that applied to bodies that size, it should have frozen solid long before anything on Earth was alive. The first thing that was already known about Triton, from Earth, long before the flyby, is that it goes the wrong way round. It orbits Neptune backwards, retrograde, against the planet's own rotation. No large moon does that. Moons that form alongside their planet inherit its spin direction. Triton did not, which means it did not form there. It formed somewhere else and was captured. The best current explanation is that Triton was one half of a binary pair out in the Kuiper Belt, and that the pair passed too close to Neptune. The gravity of that encounter split the pair. One was flung away, out of the solar system or into a distant orbit. The other was kept. That work was published in 2006, 17 years after the flyby, and it is still the leading account. So Triton is a Kuiper Belt object that was taken prisoner, and the tidal stress of settling into its new orbit would have melted it through, which gives the encounter a strange quality. This is the only close look anyone has ever had at a body from out there. The images came back showing a surface unlike anything else photographed anywhere in the solar system, before that day or since. Much of it is covered in a dimpled, cracked, ridged texture that looks unmistakably like the rind of a melon. The team called it cantaloupe terrain, and the name stuck. It is used in the literature to this day, though the formal designation for the individual hollows is something drier. Nothing else in the solar system looks like it. There is still no agreed explanation for how it forms. The southern hemisphere is covered by a vast, bright cap of nitrogen and methane ice, pink in places, stretching across most of the visible surface. There are very few impact craters. On a 4.5 billion-year-old body, that means the surface is young. It has been resurfaced, and recently. Something had been actively rebuilding the surface of this moon, recently, on a body that should have been inert for 4 billion years. The measured surface temperature is 38 Kelvin, 38 degrees above absolute zero. That is minus 235 degrees Celsius, colder than the surface of Pluto. It is the coldest world either spacecraft ever reached. I want to be precise here, rather than dramatic, because this gets overstated constantly. Triton is not the coldest place in the solar system. There are permanently shadowed craters at the moon's poles that are colder still, around 25 Kelvin. But Triton is the coldest surface with an atmosphere and a geology, and at 38 Kelvin, essentially nothing should be able to happen. Nitrogen is a solid at that temperature. Rock is brittle as glass. Any chemistry runs immeasurably slowly. And then somebody going carefully through the images, frame by frame, found dark streaks lying across the bright southern cap, all of them running the same way. Long, thin, dark markings, all running in the same direction, laid across the bright ice. They were being deposited by something. Something was putting dark material onto the ice in a consistent direction, and it was still running. At least 4 active plumes were identified in the images, columns of gas rising from the surface to about 8 kilometers, then flattening out and drifting more than 100 kilometers downwind. Geysers, erupting nitrogen, on a moon at 38 Kelvin, photographed in the act. The mechanism that was eventually worked out is genuinely beautiful, and the best part of it is that it requires no internal heat whatsoever. The southern cap is nitrogen ice, and it is slightly translucent. Sunlight, feeble as it is out there, passes through the top layer and is absorbed by darker material a meter or 2 down. That layer warms by a few degrees, not much. But nitrogen at 38 Kelvin is close to its boiling point at that pressure. A few degrees is enough. The nitrogen underneath turns to gas. Pressure builds under a sealed lid of ice, and eventually it finds a weakness and blows. It is a greenhouse, driven by sunlight 1,000 times weaker than ours, on the coldest surface Voyager ever measured. The plumes rise until the thin atmosphere stops them. Then the wind takes the dust sideways, and it settles as those dark streaks. This was the last thing the tour found, in its final hours, and it may have been the most important thing in the whole 12 years. Before Triton, the working assumption was that activity in the solar system required either closeness to the sun or a large body's internal heat. Io had already dented that. It is heated by Jupiter squeezing it, not by the sun. Triton broke it completely. Here was a small, ancient, captured body at the outer edge of the planetary system, doing geology. Sunlight that would not warm your hand was enough, given the right material. Which raises a question the mission could not answer, and which it left open deliberately rather than papering over. If a small captured moon at 38 Kelvin can be geologically active, how many other places out there are doing something, unwatched? The Kuiper Belt is full of objects like Triton. Nobody has been to any of them except one, briefly, in 2015. And that one, Pluto, turned out to have mountains of water ice, a glacier of nitrogen the size of Texas, and a surface far younger than it should be. The pattern Triton started has held everywhere anyone has looked since. The outer solar system is not dead. It was never dead. It was simply unvisited, and we mistook our own ignorance for its stillness. The whole Triton encounter, from approach to departure, lasted a few hours of one August day. Then Triton fell behind, and there was nothing left on the route. 12 years, 4 planets, 48 moons, 2 ring systems that had to be rewritten, and 1 moon that broke the rules on the way out. The planetary mission ended there, formally, on the 2nd of October, 1989, 5 weeks after the flyby. There was no more sequence to run. Everything the 2 machines had been designed, built, argued for, and funded to do was finished. Both were still working perfectly. Both had power for decades yet, and neither of them had anywhere left to go. Behind them, as they left, the geometry offered one last thing. Looking back from beyond Neptune, the spacecraft could see Neptune and Triton together, both as thin crescents, both lit from behind, receding. It took the picture. Nobody on Earth can ever have that view. You have to be past them to see them lit from behind, and only one object ever has been. That image is the last photograph either spacecraft ever took of a planet, and neither has taken one since. It is quiet and slightly out of focus, and it is my favorite frame of the whole mission. Two blue crescents going away. And then the cameras had nothing left to point at, and for a while they were simply left switched off while everyone worked out what to do. The obvious thing to do at that point was to end the mission. The spacecraft were healthy, but the science they were built for was complete, and every year of operations costs money that other missions would like. There was a serious and entirely reasonable argument for switching both spacecraft off in 1990. What was proposed instead was that they be renamed and given a new job, out where nothing had ever been measured directly. The Voyager Interstellar mission was approved to continue past the planets, into a region whose properties were entirely theoretical. The instruments that mattered for that were not the cameras. They were the ones that feel. Magnetometers, particle detectors, and the plasma wave system, which is the reason the machine, that is still talking to us today, has the particular senses it has. They kept the instruments that could work in the dark and switched off the ones that needed something to look at. But before the cameras were shut down for good, there was one more thing to take. Not a scientific observation. Nobody involved expected it to produce data of any value whatsoever, and it did not. It had been argued about for years, and it required pointing sensitive cameras back toward the sun, which carried real risk. In February of 1990, with the planetary mission over and the cameras about to be turned off anyway, they finally did it. That is where we go next, and it is the quietest thing in this whole film. A photograph that measured nothing at all. The idea was not scientific, and everybody involved knew it. Carl Sagan was a member of the imaging team, and he had been pushing for years for the cameras to be turned around before they were shut down. Not to look at anything. To take a family portrait of the solar system from outside it. By the accounts of people who were there, it was resisted for a long time, and for reasons that were entirely reasonable. Pointing the cameras back toward the sun risked damaging them, and there was always another observation with actual data attached that wanted the time. By 1990, the objection had dissolved, because the planetary mission was over and the cameras were going to be switched off regardless. So, on the 13th and 14th of February, 1990, more than 4 years after leaving the last planet, the spacecraft turned around. It was about 6 billion kilometers out, 3.7 billion miles, roughly 40 times the distance from Earth to the Sun. It took 60 frames, a mosaic, sweeping across the inner solar system, catching 6 of the planets where they happened to be. Mercury was lost in the glare. Mars was on the wrong side and caught no light the camera could use. Pluto was too faint. The frames were recorded onto the tape recorder and sent home over the following months, because at that distance, you cannot simply transmit 60 images. And in one of them, in a band of scattered sunlight caught inside the camera optics, there is a pale dot less than a pixel across. That is Earth. Everyone who has ever lived, every life and every argument, and everything anyone has ever built is inside that dot, and it is not even a whole pixel across. It sits in a beam of stray light, which is an accident of the optics. The sun was close to the frame, and light bounced inside the instrument. Sagan noted that the accident made it look as though the planet were lit deliberately, and that this was not so. He wrote about the image afterwards, at length, and what he wrote is the reason most people know it exists. I am not going to read it to you. It is his. It is easy to find, and it is better in his own arrangement than in anyone's summary. What I will say is what the picture actually is, in plain terms, because the circumstances of it are stranger than any of the words written about it. It is a photograph taken by a machine that was already leaving, of a place it could not return to, at a moment when nobody had asked for it. The scientific value of the image was, exactly as predicted by everyone who resisted it, essentially zero. It has probably done more to change how people think about this planet than any measurement either spacecraft made. There is something in that about what things are for, and whether the people who fund them always know. Shortly afterwards, the cameras were switched off for good, and that was the end of the visual record. not stored, not idled. The instrument was shut down, and the computer that controlled it was eventually repurposed for other tasks. There was no plan to ever take another image, and neither spacecraft has taken one in 36 years. What was left was a machine with no eyes at all, traveling steadily towards somewhere no instrument of any kind had ever been. The mission was formally renamed. The planetary phase was over. The interstellar phase began. The instruments that mattered now were the ones that had been secondary for 12 years, running quietly in the background while the cameras took the attention. Magnetometers to feel the direction and strength of the field around it. Charged particle detectors to count what was hitting the spacecraft, from which direction, and with how much energy. A cosmic ray subsystem, watching for the high-energy particles that arrive from outside the solar system entirely. And the plasma wave system, 2 long, thin antennas, listening to the gas itself. None of these produce pictures. They produce numbers, slowly, in a stream a few hundred bits per second wide. It is a much less photogenic mission, and it turned out to be the more important one, because from that point onward, everything ahead of it existed only as theory. Nobody had ever measured the edge of the solar system for the simple reason that nothing built by anyone had ever been anywhere near it. Everything known about the boundary came from models, from watching the sun, and from inference. And to explain what the spacecraft was flying into, I need to describe something that has no visible surface and no fixed size. The sun is not just a source of light, it is leaking. It continuously blows a stream of charged particles outward in every direction, protons and electrons, escaping the corona at hundreds of kilometers a second. That is the solar wind, and it has never once stopped in 4.5 billion years. About 1 million tons of the sun leaves this way every second. It sounds like a lot. Over the whole lifetime of the sun so far, it amounts to well under 1,000th of its mass. This wind blows outward past every planet and keeps going, thinning as it spreads. It is what makes a comet's tail point away from the sun rather than trailing behind the comet, which puzzled people for centuries. It is what pushes on Earth's magnetic field and gives it a long tail on the night side. And it carves out a cavity in the gas between the stars. That cavity is called the heliosphere, and it is the actual physical boundary of the solar system, the one that means something rather than the one drawn on posters. Not the orbit of Neptune, not Pluto, not any of the lines drawn on the diagrams in classrooms. The solar system, physically, is the volume where the sun's wind is still pushing outward harder than the gas outside is pushing in. Everything inside that bubble is in the sun's territory, shielded by its field and swept by its wind. Everything outside it belongs to the galaxy. The space between stars is not empty. It is very nearly empty, which is a different thing. There is gas out there, mostly hydrogen left over from the formation of everything, at densities of well under 1 atom per cubic centimeter. That is a better vacuum than anything achievable in a laboratory on Earth. But it is not nothing, and it has pressure, and it has a magnetic field. And the sun is moving through this gas at about 23 kilometers per second, dragging its whole bubble along with it as it goes. So the heliosphere is not a sphere. It is being pushed against on the leading side and drawn out behind, more like a very blunt teardrop. How far out the front edge sits depends on a balance, the wind pushing out, the interstellar gas pushing back, and the wind weakens with distance. It spreads over the surface of an ever larger sphere, so its pressure falls off as the square of the distance. Eventually, it drops to the point where it can no longer hold the outside back. But before the wind gets weak enough to lose that contest, something else happens first. And this is the part that catches people out. The solar wind is supersonic. It moves outward faster than pressure waves can travel through it, which means it cannot be warned about anything ahead. When a supersonic flow meets an obstacle, it cannot smoothly slow down in advance because no signal can travel upstream to warn it. So when it finally has to slow down, it cannot do it gradually. It does it all at once, in a shock. That is what happens to an aircraft going through the sound barrier, and it is what happens to the solar wind at the outer edge of the solar system. The termination shock is the surface where the wind abruptly drops from supersonic to subsonic, piles up, heats, and turns. Beyond that surface, the wind is still there, but it is slow, hot, turbulent, and no longer flowing outward. It is being deflected sideways around the bubble.
That region is called the heliosheath, and it is thick. Nobody knew how thick. And beyond that is the heliopause, the actual outer skin, where the solar wind stops entirely and the interstellar gas begins. So the boundary is not a line, it is three structures nested inside each other. A shock where the wind slows, a thick, turbulent shell behind it, and then, somewhere beyond that, the true edge. The models in the 80s and 90s put the termination shock somewhere between 75 and 90 astronomical units. The heliopause itself, the real outer skin, was expected at 90 to 100 units, and the heliosheath between the two was expected to be perhaps 10 to 20 units thick, which would take a few years to cross. All of these numbers came from theory, and every single one of them was about to be found wrong. The first spacecraft was moving outward at about 17 kilometers per second, roughly 3.5 astronomical units per year. So the crossing would happen sometime in the early 2000s, if the models were right. Through the 90s, it kept going, sending back measurements of a solar wind that was getting thinner and slower. The mission got quieter every year. Fewer people on it, a smaller budget, less to report, and long stretches with nothing to announce at all. The instruments began to be switched off one at a time to conserve power, the ones that had no job left out there. The team that ran it shrank to a handful of people, several of whom had been there since before launch. And they waited for a number to change. The particular number they were watching, year after year, was the speed of the solar wind flowing past the spacecraft. If it dropped suddenly, if the wind went from supersonic to subsonic in a matter of days, that would be the shock, and that would be the edge beginning. It nearly happened in 2002. At about 85 astronomical units, the instruments recorded something that looked like a crossing. Particle counts jumped. The signature was there. A paper was published. It was disputed almost immediately by another team reading the same data differently. And then the signature went away again, and the instruments showed the spacecraft was clearly back in ordinary supersonic solar wind, which left two possibilities. Either the measurement was wrong, or the boundary itself had moved past the spacecraft and then retreated. The second explanation turned out to be right, and it is the first thing the mission learned about the edge. The boundary breathes, in and out, on the sun's own rhythm. The sun's activity rises and falls on an 11-year cycle. When it is more active, the wind is stronger, and it pushes the whole boundary outward. When activity drops away again, the pressure falls and the whole boundary relaxes back inward. The distance involved is enormous. The shock can move by several astronomical units, hundreds of millions of kilometers, over a few years. So the spacecraft had not crossed the shock in 2002. The shock had briefly crossed the spacecraft. It caught up with the boundary properly on the 16th of December, 2004, at 94 astronomical units from the sun. The solar wind dropped abruptly to a fraction of its speed. The magnetic field strengthened. The particle counts rose and stayed up. It was through the shock and into the heliosheath, and nothing built by anyone had ever been in that region before. 94 astronomical units, about 8.7 billion miles from the sun, and roughly 27 years into the flight. The second spacecraft crossed on the 30th of August, 2007, at 84 units. 10 astronomical units closer in, nearly a billion miles closer than where the first one had crossed. Both spacecraft were leaving in different directions, and they hit the same boundary at significantly different distances. That is direct, physical proof that the heliosphere is not round, obtained the only way it could be. It is squashed on one side, and the shape depends on the direction of the interstellar magnetic field pressing on it. You cannot learn that from one spacecraft.
You need two, going different ways, and there have only ever been two.
Inside the heliosheath, things got stranger rather than clearer, which by this point in the mission was almost expected. The wind was slow, but it was not flowing outward anymore. It had turned and was moving sideways. The magnetic field became disorganized, folded back on itself, with regions where the strength dropped almost to nothing, and others where it spiked. Cosmic rays from the galaxy started to rise years earlier than expected, which meant the shielding was thinning long before the actual edge. And the region kept going and going, far beyond the 10 to 20 units the models had predicted. The first spacecraft spent nearly 8 years inside that shell, crossing something that was supposed to take a fraction of the time. 8 years, crossing a shell that was supposed to take a fraction of that. By 2012, it was at 120 astronomical units and still had not left. Every model of where the solar system ends was now demonstrably wrong, and the machine testing them was 35 years old and running on a dwindling supply of plutonium. That is where the story rejoins the beginning of tonight. I opened with the crossing because it is the thing the title promised, and I did not want to make you wait 2 hours for it. But I gave you the outline. What actually happened in 2012 took a year to establish and is worth the detail. The particles behaved exactly as predicted. The wind behaved, the cosmic rays behaved. Everything that had been agreed in advance happened on schedule. And the magnetic field, which everybody had agreed in advance would be the proof, did not behave at all. It should have swung to a new direction when the spacecraft left the sun's territory, because outside the bubble, the field belongs to the galaxy. It stayed almost exactly where it had been, and that broke the test that everybody had agreed on in advance. For a year, the mission could not say whether its spacecraft was inside the solar system or outside it. Papers were published arguing both. There was a serious proposal that it had entered a region that was neither, a kind of corridor along the boundary. The argument was settled by an instrument nobody had expected to settle it, listening to something nobody had expected to hear. And once that was resolved, the field's refusal to turn stopped being a problem and became a discovery in itself. The interstellar magnetic field, it turns out, is draped over the outside of the heliosphere rather than meeting it head-on. It wraps around the bubble as the sun plows through, like water around a slow-moving hull, and where it wraps, it is dragged into alignment. So, just outside the boundary, the galaxy's field is temporarily bent into nearly the same direction as the sun's. That is why it did not swing. The spacecraft had crossed into a region where the two fields happened to be almost parallel. It took years and a second crossing in 2018 to establish that properly. The second spacecraft, arriving at a different place on the boundary, saw the field rotate by about 20 degrees. 2 crossings, 6 years and a considerable distance apart, and neither one looked like the models. This is what I meant much earlier about the difference between predicting something carefully and actually going to measure it. Everything about that boundary had been worked out carefully in advance, by people who were very good at it, using the best physics available. And then 2 machines built in the 1970s arrived and found it further out, differently shaped, with a field that would not behave and a crossing that took years. None of that is a failure of the models. It is what models are for. They told us where to look and what would be surprising. But it does mean something worth holding on to. Every diagram of the solar system drawn before 2004 had its outer boundary in the wrong place, and the only way anyone found out was to send something. The rest of tonight is about what it heard once it got there, what that turned out to mean, and what happens to it from here. By the summer of 2012, the first spacecraft had been inside the heliosheath for nearly 8 years. It was 121 astronomical units out. Everything the models had predicted about this region had already failed. The team was watching 3 numbers, and they had agreed in advance what a crossing would look like. The count of low-energy particles originating inside the solar system should collapse, because those particles cannot exist outside the bubble. The count of high-energy cosmic rays from the galaxy should jump,
because outside there is no longer any shielding.
And the magnetic field should rotate, because outside the bubble, the field belongs to the galaxy and points a different way. 3 signatures, agreed in advance, all of which had to happen together before anyone would announce anything. That was the arrangement. In late July, the particle counts began behaving oddly, dropping sharply, then recovering, then dropping again a few days later. 5 separate times over about a month, the spacecraft appeared to step outside and then back in. That is not instrument noise. The boundary itself is not a smooth surface. It has structure, and it moves. Then, over a few days at the end of August, it stopped coming back, and the numbers settled into their new values and stayed. On the 25th of August, 2012, the low-energy particles from inside the solar system essentially vanished, down by more than 99%. The galactic cosmic rays rose to a new level, about 9% higher, and stayed there. 2 of the 3 signatures, arriving cleanly and unambiguously within days of each other, exactly as predicted decades earlier by people mostly retired by then. And the magnetic field did not turn. It stayed within a few degrees of the direction it had held for years, as though nothing whatsoever had happened. So the mission had a spacecraft where 2 of 3 agreed signatures said it had left the solar system, and the third said it had not. There was no procedure for that. What followed was more than a year of genuine scientific argument, conducted publicly, between people who had worked together for decades. One camp held that the particle data was decisive, that 2 out of 3 was enough, and that the field would be explained in due course. Another held that the field was the criterion, that leaving the sun's magnetic domain is what leaving means, and that the spacecraft was in some new region inside. There were papers proposing exactly that: a depletion region, a corridor, a magnetic highway along the edge, still technically inside. That last name stuck for a while, and it describes something real that was observed in June of 2012. For about 2 months before the crossing, the field lines aligned themselves radially, and particles began streaming along them, in and out, as though along a channel. It was a genuine structure, it was clearly real in the data, and nobody had predicted anything like it. But it was not the answer to whether the spacecraft was in or out. The instrument that eventually settled the argument was not one of the 3 the test had been built around. Nobody had expected it to have anything to say. The plasma wave system. 2 thin antennas, 10 meters each, sticking out from the spacecraft at right angles to one another. Here is what it does, because it is the heart of everything that follows. The gas out there is a plasma, atoms stripped of their electrons, so the charges move independently. A plasma has a natural frequency. Push the electrons in it, and they oscillate back and forth against the ions at a rate that depends on one thing only: how densely they are packed. Not temperature, not magnetic field, not what the gas is made of, only the number of electrons in a given volume. So if you can hear the plasma ring, you can calculate its density directly, with no model in between and nothing to assume. It is the cleanest measurement in the whole discipline. The catch is that the plasma has to be wrung. Something has to disturb it, and out there almost nothing does. In October and November of 2012, something did disturb it, and the instrument was listening. The instrument picked up oscillations at about 2.6 kilohertz, lasting weeks. Run that frequency through the arithmetic, and it gives an electron density of about 6/100ths of a particle per cubic centimeter. For comparison, inside the heliosheath, the density had been around 1,000th of a particle per cubic centimeter. This was roughly 60 times denser. That is not solar wind. Solar wind does not get denser as you go outward. It thins. Denser gas means interstellar gas, which is compressed where it piles up against the outside of the bubble like water against a hull. Then, in April of 2013, it happened again, at a slightly higher pitch. 8/100ths of a particle per cubic centimeter. Denser still than the first reading, taken 5 months and several 100 million kilometers further out. 2 measurements, months apart, both giving densities that only make sense outside the heliosphere,
and rising as it went. That was the proof. Not the wind stopping, the gas singing at the wrong pitch for home. Working backwards from the density trend, the team could place the actual crossing, and it landed in August of 2012, where the particle data had said all along. NASA announced it in September of 2013. 13 months after the event it was announcing had already happened. The spacecraft had been in interstellar space for over a year before anybody could say so with confidence. That delay is not embarrassing. It is the correct amount of caution for a claim nobody could ever check independently. There is only one spacecraft out there. There is no second opinion, and there will not be one for decades.
The distance was 122 astronomical units, roughly 18 billion kilometers, 20 to 30% further out than every model had put it, which is not a small correction on a number that large. The solar system, defined physically rather than by where the planets happen to stop, is substantially bigger than anyone had calculated. The second spacecraft crossed on the 5th of November, 2018, at 119 units. It had a working plasma instrument that the first one had lost decades earlier, so it measured the density directly at the boundary rather than inferring it. And this time, the magnetic field did rotate at the boundary by about 20 degrees, which is small but unmistakable. So the field does turn at the boundary, just not everywhere, and not by much. The explanation that emerged is that the galaxy's magnetic field is draped over the heliosphere like fabric over an obstacle. Where it drapes, it is pulled into alignment with the field inside.
So just outside the boundary, the two are nearly parallel, and a crossing produces almost no rotation. The first spacecraft crossed in a place where the drape was tight. The second crossed where it was looser. Neither result was wrong. The test had simply been designed decades earlier, without anybody knowing that the boundary has structure and weather of its own. The first sound, though, raised a question of its own, and it took years to answer. Those oscillation events were bursts. They lasted weeks and then stopped. Something had to be striking the gas to make it ring, and out there the list of candidates is short. The answer is that the sun reaches much further than its own bubble. When a large solar eruption happens, a coronal mass ejection, a few billion tons of plasma thrown off the sun, it travels outward as a pressure wave. The wave keeps going after the solar wind carrying it has stopped at the boundary. It passes through into interstellar space and shakes the gas there. The team called them tsunami waves. The first arrived in late 2012, a second in the spring of 2013, a third in early 2014, a fourth the year after. Each one took roughly a year to travel from the sun out to the spacecraft, arriving long after the eruption that caused it had been forgotten. Each one rang the interstellar gas as it passed, and each ring gave another density reading further along the path. So the sun was, unintentionally, running an experiment. Every large storm sent out a probe pulse, and the spacecraft measured the response. 14 years past the border, weather from home still arrives out there, months late and much diminished, but arriving. That is harder to sit with than the distance is. It left, and it is still not entirely out of the house, and it is not clear at what distance it finally will be.
There is a version of the departure that is clean, a boundary, a crossing, and then the galaxy. That is not what happens. What happens is that the sun's influence thins out over an enormous distance and reaches after it, weakening for years. The waves also revealed something about the gas itself that nobody had gone looking for and nobody had predicted. The density readings taken from successive events did not agree with each other, and the disagreement was not random. Between 2012 and 2016, the measured density kept rising, a smooth ramp rather than a single value. So the gas just outside the heliosphere is not uniform. It is compressed against the boundary and thins out with distance. There is a pileup of material pressed against the outside of the bubble, and the spacecraft was flying slowly through it. That is a structure nobody had described, found because a star had storms and a machine happened to be listening. But between the storms,
In the long gaps that lasted months or years, there should have been complete silence. The instrument should have recorded nothing at all in the gaps, no source, no signal, flat. And for 5 years, everyone assumed that was the case, because that is what the data looked like at the resolution people were examining it. The gaps were, by definition, where the interesting events were not happening. Nobody had a reason to look there, and for 5 years, nobody did. This is a recurring shape in this story, and it is worth naming. Almost every major result on this mission came from someone examining the part of the data that was supposed to be empty. Jupiter's ring came from a single deliberate long exposure, 11 minutes and 12 seconds, aimed at a place expected to hold nothing at all. Io's volcano came from brightening the black edge of a navigation frame to find background stars. And the last discovery of the whole mission came from a graduate student going carefully through the quiet stretches between the storms. Her name is Stella Koch-Ocker, and at the time she was a doctoral student at Cornell, working on data from a spacecraft launched 2 decades before she was born. She was working through the plasma wave data, looking specifically at the intervals everyone had treated as background. They were not empty. There was a signal running through all of them, in every gap, in all the intervals, without a single interruption. Very faint, very narrow, and it did not stop. About 3 kilohertz, in a band only 40 hertz wide, almost a pure tone rather than a noise. It had been running continuously since 2017, through more than 10 astronomical units of travel, entirely unnoticed. This is the hum. It is a distinct thing from the oscillation events, and the two get confused constantly, including by people who should be careful. The events are bursts at 2.6 kilohertz, caused by solar storms arriving. They come and go. The hum is a continuous emission at about 3 kilohertz, with nothing striking the gas at all. The interstellar medium, left entirely alone with nothing striking it or disturbing it, makes a sound of its own accord. It is not loud. It would not be loud even if you could stand there, which you could not. And to be exact about what that means, because this is where these stories usually become dishonest. There is no sound out there in the sense of something you could hear. There is no air to carry a pressure wave to an ear. What the instrument measures is an oscillation in the plasma, a rhythmic movement of charged particles at a particular frequency. That frequency happens to fall inside the range human hearing covers, so it can be played through a speaker directly, without shifting it. It is not a metaphor, and it is not a sonification of unrelated data. It is a real oscillation, at a real frequency, in a real medium. It simply is not traveling through air, and nothing out there could hear it. The density it gives is about 11/100ths of a particle per cubic centimeter, and it varies as the spacecraft moves, which is the whole point. And because the pitch tracks the density continuously, the hum turned a nearly blind spacecraft into an instrument nobody had designed. A continuous gauge of the gas between the stars. A reading every 3/100ths of an astronomical unit, year after year. Before this, the density of the local interstellar medium could only be sampled when a storm happened to arrive, a few times a decade. Now it is measured constantly, by a machine with 2 working senses, 14 billion miles away, running on a dwindling supply of plutonium. That result was published in 2021, 44 years after launch. It is, to my mind, the single most surprising thing in the whole 49 years of this story. Not because it is the largest discovery, it is not, because of what it was made with, and by whom. A spacecraft designed to photograph Jupiter, built with less memory than a single one of your photographs, that had already outlived its mission by 4 decades. And a doctoral student who decided to look carefully at the part of the data everyone else had classified as boring. So here is what is actually out there, as measured directly by something standing in it, rather than modeled from 120 units away. The gas is about 1/10 of a particle per cubic centimeter. On Earth, a cubic centimeter of air holds about 25 million trillion molecules. The temperature is somewhere between 30 and 50,000 Kelvin, which is hotter than the surface of the sun.
That sounds impossible sitting next to everything else said about the cold of deep space.
And both things are true at the same time. Temperature measures how fast individual particles move. Those particles move very fast indeed, but there are so few of them that they carry almost no heat. An object out there would radiate away far more energy than the gas could deliver. You would freeze in a furnace. Both statements are correct, and neither is the whole picture. The magnetic field out there is about half a nanotesla, and this is the number most often got wrong. Earth's field at the surface is around 50,000 nanoteslas, so the interstellar field is roughly 100,000th as strong. It is worth stating that carefully, because the figure is very often quoted 100 times too high, and the error survives because nobody checks it. The pressure is around 3 billionths of a millionth of a pascal. Sea level here is about 100,000 pascals.
These are the conditions in the space between stars, and until 2012, every number in that list was an estimate. Now 4 of them are measurements from 2 instruments on 2 machines in 2 places, 6 years apart. That is the entire in situ record of interstellar space. There is nothing else, and nothing else is coming soon. There is a mission concept for a dedicated interstellar probe, something built for this from the start rather than repurposed. The proposals would launch in the 2030s and take 20 to 30 years to get somewhere useful. The people writing those proposals are entirely aware that they may not live to read the results, and they are writing them anyway. One more thing about that boundary, and then we can leave it behind for the rest of the night. The models had also predicted a bow shock ahead of the heliosphere, the structure that forms ahead of a boat, where the medium is pushed aside faster than it responds. It appears not to exist at all, and finding that out required a different spacecraft entirely. Measurements from a separate spacecraft in 2012 showed the sun is moving through the local gas more slowly than had been thought, slowly enough that no shock forms. There is a bow wave instead, a gentler pileup without the abrupt front. So the picture that stood for decades, a bubble with a shock ahead of it, plowing through the galaxy, is wrong in its most drawn detail. Every diagram of the solar system's outer boundary printed before about 2012 is inaccurate in the distance, the shape, and the leading edge. And the only reason anyone knows is that 2 machines built in the 1970s kept working long enough to arrive. Both of them are still out there tonight, still transmitting, still measuring, still adding to a record that has no second source. For now. Everything on board runs on heat. 3 canisters of plutonium sealed in 1976, each one decaying at a rate fixed by physics and untouchable by anyone. The heat is turned into electricity by a solid-state device with no moving parts, which is why it has lasted. There is nothing in it to wear out. But the plutonium is running down on its own schedule, and the conversion into electricity gets less efficient as the materials age around it. At launch, each spacecraft had about 470 watts to work with. Today, it is around 249 and falling. It loses roughly 4 watts every year, and nothing can be done about that. 4 watts does not sound like much until you consider what it costs to keep an instrument warm at 200 degrees below zero.
So for the last 15 years or so, the mission has been making a particular kind of decision, over and over, and there is no way to avoid it. Which instrument to switch off next? Not because it failed, and not because it stopped being useful, because there is no longer enough power to run everything, and something has to go. They are chosen carefully. What is this instrument still learning? What would we lose? What else could use its watts? The cosmic ray subsystem, one of the instruments that proved the spacecraft had left the solar system, was switched off in February of 2025. The low-energy charged particle instrument followed it into silence in April of this year, a few months ago. On the first spacecraft, 2 are left running: a magnetometer, which feels the field, and the plasma wave system, which listens. The instrument that found the hum is one of the last 2 still working, and that is not a coincidence. It was kept precisely because it is the one still returning something that no other instrument anywhere can provide. There is a particular quality to these decisions that I have not been able to stop thinking about since I read how they are made. Somewhere there is a document, updated periodically, that lists what remains and the order in which it will go. People who have worked on this for 30 or 40 years sit in a room and decide which sense the machine loses next. Then a command is sent, and it takes almost a day to arrive, and something that has been running since 1977 stops. The current estimate is that there will be enough power for engineering data, the spacecraft reporting on its own condition, into the mid-2030s. Science data will stop before that. Instrument by instrument, one decision at a time, until there are none left running. And then, at some point, the transmitter will no longer have enough power to be heard, and there will be silence. No one will know the exact moment. It will be a scheduled contact that produces nothing, and then another one. Before any of that, in a few months from tonight, there is one more mark to pass. On the 18th of November, 2026, the first spacecraft will be one light day from Earth, 25,902,000,000 kilometers, 16 billion miles. A radio signal will take a full 24 hours to reach it, and another 24 to come back. Ask it a question in the morning, and the answer arrives the day after tomorrow. It is the first object made by anyone to reach that distance, and it will hold that record for a very long time. The number is arbitrary. It is a human unit, applied to a machine that does not measure anything in days. But I like it, because it converts distance into something you can feel in your own life. Light is the fastest thing there is. Nothing carries information faster, and the fastest thing there is now needs a full day to get from here to something we built and launched within living memory. That is the distance one machine covered in 49 years, going 17 kilometers per second and never slowing. The nearest star is about 4 light years away, 4 years at the speed of light. And we are, after half a century of the fastest departure ever managed, 1 day out. That ratio is the honest scale of the thing, and it is the reason all the talk of reaching other stars stays talk for now. Hearing it at that distance already takes equipment and techniques that did not exist when it launched, and did not exist when it passed Neptune either. The transmitter puts out about 23 watts. By the time the signal arrives, it is spread across a beam wider than the Earth. In April of 2024, for the first time, 6 antennas in Madrid were linked together and pointed at it simultaneously, combining their collecting power to catch it. 6 dishes spread across a site in Spain, working as a single instrument to hear something dimmer than a refrigerator light at 14 billion miles. There is a way of telling this that sounds like slow decline, a fading signal, ever more effort for ever less. I do not think that is what it is. The spacecraft cannot be improved. So for 49 years, the response has been to improve the ground instead. New antennas were built. Old ones were rebuilt. Radio observatories with no connection to spacecraft tracking were borrowed for encounters. The receivers were chilled closer and closer to absolute zero to pull the signal out of the noise. The software was rewritten repeatedly, on Earth and on board the spacecraft itself. A machine designed in the 1970s is still being heard because 2 generations of people decided it was worth the effort of keeping up. Nobody was ever assigned that as a career path. There was no plan for it. It simply kept being true, year after year, that it mattered enough to continue. After the silence, nothing happens to either of them for a very long time indeed. The spacecraft does not stop. There is nothing to slow it, no air, no friction, and it is far past the point where the sun's gravity can meaningfully pull it back. It will keep going at about 17 kilometers per second in the direction it is pointed, essentially forever. In about 300 years, it reaches the inner edge of the Oort cloud, the shell of icy bodies that surrounds the solar system at enormous distance. It takes roughly 30,000 years to cross it. The Oort cloud is not crowded. The objects in it are separated by tens of millions of kilometers.
It will almost certainly pass through without coming near anything.
Then it is out, genuinely, into the space between stars, and it begins the part of its existence that is measured in tens of thousands of years. In the year 40,272, more than 38,000 years from now, it passes within about 1.7 light-years of a small red star. That is the closest it will come to anything for a very long time, and 1.7 light-years is not close. It is nearly half the way to the nearest star. The star will not notice. Nothing will happen. It will simply be, briefly, in the vicinity of something. The second spacecraft, heading the other way, makes a comparable pass by a different star on a similar timescale. After that, both of them settle into a long orbit around the center of the galaxy, which is what everything here is doing anyway. That is the part people often miss.
They are not leaving the galaxy. They never had anything like the speed for that. They are in orbit around the Milky Way's center, as the Sun is, taking a couple of 100 million years to go round once. So they will come back through this region of the galaxy repeatedly, over hundreds of millions of years, though the Sun will not be where they left it. They will outlast the thing that built them by an amount that is genuinely difficult to hold in mind. There is nothing out there to erode them. No weather, no oxygen, no water, and almost nothing to hit. The main slow damage is cosmic rays and micrometeoroid impacts, and both are extremely rare at that density. The estimates for how long the golden record itself remains readable run into the hundreds of millions of years, and possibly longer. Which means that of everything our species has made, the objects most likely to still exist in a billion years are two 1970s spacecraft, and the aluminum covers bolted to their sides. Not our buildings, not our monuments, not the pyramids, and not anything else we deliberately built to outlive us. Two machines that were funded for 5 years and a gold-plated copper disc assembled in 6 weeks by a committee. The chance of anyone ever finding one is, as everybody involved said openly at the time, effectively zero, and nothing since has improved those odds. Space is too large, and they are too small and too dark, and moving through a volume where nothing is looking. There are things about all this that are genuinely not known, and I said at the start I would be clear about which. Nobody knows exactly where the heliopause sits on most of its surface. 2 crossings, 6 years apart, is the entire sample. Nobody knows how thick the pileup of gas outside it really is, or how far the hum will keep being audible as the spacecraft moves into thinner material. Nobody knows what makes the cantaloupe terrain on Triton, or the spokes in Saturn's rings, or why Miranda looks the way it does. Nobody knows whether there are more places out there like Triton, small, cold, and quietly active, because almost nowhere has been visited. And nobody knows how long the two of them will actually last, because every previous estimate has been too pessimistic. They were built for 5 years. They were expected to fall silent shortly after Saturn, then after Neptune, then in the 2000s. Each time, the people running them found another few watts, another workaround, another instrument that could be turned off to buy a year. It is possible that the current estimate is wrong in the same direction as all the others. Knowing the record, I would not bet against it happening once more. What stays with me is the shape of the whole thing, which nobody designed and nobody could have proposed. A 5-year mission to photograph 2 planets became a 12-year tour of 4. The tour became a slow departure into a region that nobody had funded anyone to visit. The departure became the first, and so far only, direct measurement of where the solar system actually ends. And the machine that was almost blind by then, running on 2 instruments, found a sound in the gas that nobody knew was there. Not one of those steps was planned. Each one happened because something worked longer than it was supposed to, and somebody noticed what that made possible. There is probably a lesson in that about how discovery actually goes, as opposed to how it is described afterwards. But I am wary of tidy lessons at this hour, and the facts are better than any moral I could put on them.
So I will just say plainly what is true tonight while you are lying there. There is a machine 49 years out from here, losing 4 watts every year, with 2 working senses left out of the 11 it launched with. It is listening to gas between the stars and sending back what it hears at a few hundred bits a second. In November, it will be 1 light day away. Sometime in the next 10 years or so it will stop, and nobody will be able to say precisely when. And then it keeps going anyway, carrying whale song and thunder and greetings in 55 languages into a place where none of it will ever be heard. It was built by people who knew they would not see how it ended. Most of them were right. It is very far away, and it is very small, and it does not know any of this. But it is still working tonight, while you are lying here. And it will still be working tomorrow, and probably for a while yet. There is nothing out there you need to reach, nothing here you need to remember. Let it run long and low, the way a radio wave does. Rest easy, sleep well. Good night.